Let me give you a quick summary of everything. In this video, we're going to talk about probability terminology. This word here, terminology. Terminology means special or technical words. So when you're learning about something new, you often need special or technical words to 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 be able to communicate with each other. So terminology means special or technical words. So, for example, independent events. Well, independent events or events that are, well, independent of each other. So, for example, if you roll two dice, when you roll two dice, you can imagine it as rolling one die at a time. Roll one die, and then roll the second die. Well, the outcome of the second die is independent of the first die. It means that when you roll two dice, the outcome of the second die has nothing to do with the outcome of the first die. So the two events are independent of each other. They're not connected in any way. The same with the spinner here. If you spin this arrow here, if you spin it and then spin this one here, the outcome of the two events are independent of each other. It means that they are not connected in any way. And also, if you have a bag of balls here, black balls, purple, and white. If you were to pick out one ball, take note of the color, and then put that ball back, and then give it a shake, and then pick out another one, then the two outcomes here, they are independent of each other. The two events are independent of each other. Okay. For conditional events, or when they're connected. So for example, if you have a bag of balls here, if you pick out a ball, and in this case, we are not going to put it back, and then you up here, remember, up here we are picking out a ball, and then take note of the color, and then we're putting it back. So, and then, well, down here we are not going to put it back. We are just going to pick out, let's say, three balls, one, and then pick out another one, and then pick out another one. Well, the events here, they're conditional. They're not independent. So when you come to draw your tree diagram for this this situation here, the tree diagram would look like this: black, white, purple. Okay, and then on your second pick, it would be like this. Well, what I'm saying, the probability of you picking out a black one here would be 2 out of how many? 5 out of 10. 2 out of 10. Probability of you picking a white one would be 5 out of 10. Probability of you picking a black one will be 2 out of 10. And when you come to, well, pick out your second ball here, it would look like this. Hang on. Suppose you just picked out a black ball. The probability of you picking out another black ball would be 1 over 9. You see, conditional events here, or events that are well conditional to the outcome of the first event. So here, the outcome of the second event here is, well, dependent on the outcome of the second event. If had you gone down this route here, the probability of you picking out another white ball would be 4 out of 10. You see, the condition, the probability of the second event is dependent on the outcome of the first event. So with conditional events, the outcomes are connected to each other. The same with the packet of cards. If you pick out, let's say, if you were to pick out two cards, what is the probability that both of these cards will be hearts? So your tree diagram would look like this: heart, not heart. And then on your second card, it would be heart, not heart. Well, so what's the probability of you picking out a heart on your first card? It would be 13 out of 52. Probability of you getting another heart would be 12 out of 51. You see, the outcome of the second event is dependent on the first one. So when the outcomes depend on each other, the events are said to be conditional. Okay, up here they are independent. Okay, okay, and the other one is mutually exclusive. Well, mutually exclusive means, for example, if you look at the die, what the outcomes are mutually the outcomes could be 1, 2, 3, 4, 5, 6. They are mutually exclusive because two events cannot happen at the same time. So when you spin this, you could get a 1, 2, 3, or 4. You can't get both. So mutually exclusive means the outcomes are, well, you can only get one outcome at a time. So hang on, let me give you an example when it's not mutually exclusive, and then you see what I mean. So for example, not mutually exclusive. If you were to pick out a card, what is the probability of you getting a heart, or let's say a picture card? Well, picture card, we're going to define picture cards as these cards here. Well, here you can see there's an overlap. So the event, well, here you've got event of picture and an event of hearts. Well, the two are not mutually exclusive. They overlap. So here, well, mutually exclusive means mutually exclusive means, for example, let's say hearts or clubs. You see, the two events here are mutually exclusive. When you come to pick out a card, you cannot pick out a card where it satisfies this condition and this condition. They are mutually exclusive. Now, when it's not mutually exclusive, if you pick out, let's say, one event would be picture card, and another event would be hearts. Well, it is possible to pick out. It is possible to pick out one card where it satisfies a picture card and hearts as well. Well, if you pick out, let's say, Queen of Hearts, then this outcome here satisfies this and this. Now, mutually exclusive, let's say clubs and diamonds here. They are mutually exclusive because you cannot pick an event where it will satisfy two conditions here. Okay, so when you come to draw a Venn diagram, let's say a Venn diagram here, A and B. Well, A and B are not mutually exclusive because there's an overlap here. Okay, are mutually exclusive. If you were to roll a die here, let's say this is a die here, you could get a 1, 2, 3, 4, 5, and 6. You see, all these are mutually exclusive. The Venn diagram for the die would look something like this. They're mutually exclusive. All the events are mutually exclusive. If you draw a Venn diagram for, let's say, a picture and a heart, so this could represent picture and this could represent hearts. There are three cards here that exist in the middle here because it's the three cards here satisfy picture and hearts. So the events here are not mutually exclusive. Okay, and also when you're talking about Venn diagrams, let's have a look at this. When you're talking about Venn diagrams, this is called the intersection. Okay, yeah, it's called the intersection. And if you're talking about a Venn diagram here, the union of the two would be all these here. Okay, the union of the two. And I've explained union and intersection before. So if you don't understand, then scroll back to some of the earlier videos. Okay.